In this series of discussions on the thermodynamics of electrochemical shell, today I shall discuss this glass electrode. And this glass electrode is a very special type of electrode which does not involve the electrons or its oxidation reduction reactions as we have found in other type of electrode reactions. And you see, this is a special type we call the ion selective membrane electrode. This type of electrode actually getting much more momentum recently, as this electrode is specific for a particular type of ion. Say, suppose sodium ion present in a solution with other ions. Once ion selective membrane, if we put there, then it will be sensitive only to the sodium ions and not with the other ions present in these solutions. Naturally, this sodium ion, potassium ion, etc., which are very popular to estimate, these could be determined by means of ion selective electrodes. And now in polymers, several thin membranes are devised sensitive to a particular ion in solutions. This glass electrode is a class of this type of electrode, and it is sensitive only the hydrogen ions present in these solutions. The concentration of hydrogen ions and hence the pH of this solution could be determined by means of a glass electrode very safely and accurately with the accuracy of plus minus 0.5, and it can be used to determine the pH of a solution up to 0 to 12, and it may extend to 0 to 14 with a special type of glass. And we know the structure of this glass. This glass contains 72% silicon dioxide, 22% sodium oxide, and 6% calcium oxide. So this is the composition of a typical glass, and the structure of this glass is actually super cooled liquid, and it is not this crystalline forms, but the structure is like that: silicon oxygen 3D networks, silicon oxygen covalent bonding with a 3D structures, and this is this type of the structure approximately I can describe for this glass. And the sodium ion, and this is the cavity, and this is the space, and within which this sodium ions and calcium ions can retain within this space. And you know, the sodium ion actually can move through this glass membrane through this nanopore channels, and make it slightly conducting. We generally used a very thin glass membrane, and this is thickness I can say thickness approximately 0.005 centimeter. Still then, so much very thin, actually that of the size of this A4 paper, and it has this resistance approximately equal to 10 to the power 7 to 10 to the power 9 ohms with an average I can say 10 to the power 8 ohms. So this glass membranes, this is the description. So the preparation of this glass electrode is that the membrane is soaked or dipped in a solution in pure water for a few hours, so that this sodium ions within this glass surface or near the glass surface will exchange with the hydrogen ions in water, and hydrogen ions will replace this sodium ions, and this surface of this glass membrane contains this hydrogen ions. And when this solution dipped in acid solutions, this membrane, when you are dipped in acid solutions, so there is an equilibrium between these hydrogen ions present in this glass surface and with this test solution whose pH is to be determined. So I can say the preparation of this glass electrode or the picture of this glass electrode is shown in this way, and this is the silver chloride. This silver chloride, this is this glass membrane, thin glass membrane of this size is 0.005 centimeter, and internally this tube is this is a glass tube filled with 0.1 mole hydrochloric acid, and within which this silver chloride terminal is dipped. This silver chloride and internally filled hydrochloric acid acts as a connecting externally with this other electrode, and here lies this test solution. Here lies the test solutions. So I can give you there is an equilibrium. Here is also the hydrogen ions, and within this glass membrane also hydrogen ions. So actually hydrogen ions in glass membrane remains in equilibrium with this hydrogen ion in acid solution. So this exchange of the hydrogen ions occurs through this glass membrane. It is neither the oxidation nor the reduction or not the electrodes are involved in this type of electrode potential. So how the potential is developed? So I can say this is like so many theories are there. So many theories are there to explain the mechanism of this glass electrode, but actually I like this boundary method, which is just like the liquid junction potential. Here the hydrogen ions within this surface of this glass membrane, here the hydrogen ions is higher concentration, here the hydrogen ions within this glass surface is lower concentration. So this just potential junction potential, similar to liquid junction potential, it is also, I can say, the boundary potential, and this is the potential of this glass electrode is equal to T minus T hydrogen ion and RT by F ln activity of this hydrogen ion in glass and activity of hydrogen ion in solution, in acid solution. But here only the hydrogen ions are permeable through this glass electrode, and so T minus equal to 0 and T plus equal to T hydrogen ion equal to 1, and activity, so this can be written as minus RT by F ln activity of hydrogen ion in glass minus RT by A into ln 1 by activity of hydrogen ion in solutions. This one is the concentration of this outer solution, so whose pH is to be determined or activity of hydrogen ion is to be determined. At 25 degrees centigrade or say 298 Kelvin, this one is equal to minus RT minus 0.059 log activity of hydrogen ion in glass minus 0.059 and log 1 by activity of hydrogen ion in solution. So this hydrogen ion concentration in this hydrogen ion concentration within this glass surface is fixed. This one is fixed, and this will vary from glass to glass. This depends on the type of this electrodes. So this is constant, and we can write this Eg naught, called this asymmetric potential. Asymmetric potential. Asymmetric potential, and this potential will vary depending on this type of this glass, and minus 0.059, and this one actually we call this a pH of the solution. So this glass electrode potential is now easily supplies the data to calculate this pH of this acid solution on which this electrode has been dipped. This glass electrode, normally what we do, actually this glass electrode is coupled with a secondary reference electrode, and just like the saturated calomel electrode, and in this case we can make a cell, and here another secondary cell. This one is secondary, this one is the secondary external glass liquid junction, external liquid junction used as the salt bridge. Here the mercury, here the mercury plus mercurous chloride, here the saturated KCl solution, and this is the platinum. And this one is the second electrode, this one is the first electrode, and these two are connected to a device so which will record the cell potential. If we write this cell potential, actually, then it is represented as silver, and silver chloride is solid, and here 0.1 molar HCl, and it is the glass membrane. And now this test solution or acid solutions of unknown pH, and here the saturated calomel electrode. This one is the positive terminal and this one is the negative terminal of the shell. So if we write this cell potential, each cell is equal to electrode potential of the right hand side, means E saturated calomel minus Eg. So this one actually 0.2415 or minus, instead of Eg we can write this one Eg naught, and maybe taken as common, and then plus 0.059 and pH. This is the expressions for this cell potential of this cell. This one is this secondary standard electrode, reference electrode, whose potential is known, this one, and this will also vary. So what we shall do, actually in this case, this acid solution is kept as buffer solutions of known pH. Suppose pH, then it is E1 equal to 0.2415 minus Ej naught and plus 0.059 and pH1 is the pH of the buffer solutions of known pH value. So this E1, if we can determine, this one is also known, then this constant we can find out. Then this buffer solution here is replaced by a solutions of unknown pH, and suppose E in this case is equal to 0.2415 minus Ej naught and plus 0.059 pH. So if we subtract, then E minus E1 equal to, this will cancel, so 0.059 and pH minus 0.59 common and pH minus pH1. This is the usual method to use to determine this pH of the solution. This is the pH of this buffer solutions, known value, and this is the pH of this unknown solutions, which is to be determined. E1 is the potential of this cell with this buffer solutions, and this is the potential of this cell with the unknown acid solutions, whose pH is to be determined. So if this can be used to determine this pH value, main problem is that this cell potential could not be determined by means of an ordinary potentiometer, as this cell produce this potential. Suppose potential of this cell is equal to, suppose 1 volt, suppose, and this the resistance is equal to 10 to the power 8 ohms. So this current internal, this is the internal resistance of this glass electrode, taking aside the internal resistance of this saturated calomel electrode, and this I equal to E by R equal to 1 into 10 to the power minus 8 ampere. This small current strength, this galvanometer in ordinary potentiometer cannot read. So special type of high input impedance voltmeter is used, or the vacuum tube potentiometer is also used to record this much small current strength of this cell. This is the one sort of limitations or disadvantages I can also say. Now I can say what are the advantages and disadvantages of this of this method. This electrode is very advantageous. No electrons are involved, only the exchange of ions are there through this boundary, and sometimes this is why it is also called the boundary potential of this glass electrode. And the advantageous is that this equilibrium between this glass, between the hydrogen ions within the glass and the hydrogen ions within the solutions is very quickly attained. This is one advantage. And the second advantage, this glass electrode can be used to determine this pH of 10 to the power of 0 to 14 with an extension of 0 to 14 with a special class, and with a very accurate value of plus minus 0.05. This is advantage. Not only that, a glass electrode can be used in a solutions containing the other ions also. This glass electrode only sensitive to the hydrogen ions and not to the other ions. Its value does not depend on the presence of this oxidizing agent, reducing agent. Oxygen is not to be removed, and the protein error or the poison, nothing will affect this cell potentials. So, and this is also handy, and this set is used in a very compact form, and which we call the pH meter. Only the disadvantage, the ordinary potentiometer could not be used. One problem, and second problem, the highly sensitive, so the electric wires, connecting electric wires should be properly insulated to avoid the electrical interference. And the third is that this glass membrane is very thin and can be broken easily, so it is to be handled with much care. These are the limitations also. So this is all about this glass electrode, and I think all the type of electrodes I have already covered. And if you have any problem or if you have any doubt, you can contact me with my phone number. Mobile number is 9434391759, and another is 89187888088. You can contact with these phone numbers to ask any questions. I shall try to remove any doubt if possible for me. Not only that, the printed copy of this note, you can have it from this Kalimata Xerox, which is situated at Bakura near the Karjuridanga Mall. Next day I will supply the phone number of this Kalimata Xerox, so you can get there the printed copy. Thanks you all for watching this video, and I shall be pleased if you like it and subscribe.